Hello students, welcome to this lecture one some applications of trigonometry. Okay, so here in this lecture we'll discuss exercise 9.1. So let's get started. So in first number question, here we have a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. And here find the height of the pole, and if the angle made by the rope with the ground level is 30 degree. Okay, so we have given this picture. So this is basically, so a circus artist is climbing this 2-meter long rope. Okay, so this is our 20-meter long rope, and which is tightly stitched and tied from the top of a vertical pole, and this is our vertical pole to the ground. And we have to find the height of the vertical pole, that is we have to find AB, and if the angle made by the rope with the ground level is 30 degree, so this is angle of elevation, so angle of elevation is 30 degree. Okay, so let us solve it. So it can be observed from the figure that AB is the pole. Okay, so in triangle ABC, here basically we'll use trigonometry ratio sine. Okay, so sine involve AB and AC. Okay, so that is why we use trigonometry ratio sine. So sine 30 degree, this is equal to AB by AC. So AB by AC, this is equal to sine 30 degree, and we know the value of sine 30 degree is equal to 1 by 2. So AB by AC is equal to 1 by 2, and here we have given the length of the rope, that is AC is equal to 20 meter. So AB by 20 is equal to 1 by 2. Okay, and so AB is equal to 20 by 2, that is equal to 10. So then therefore the height of the pole is 10 meter. Okay, so the height of the pole is 10 meter. So now let us move to next question. So in next question, here we have a tree breaks due to storm and broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it, and the distance between the foot of the tree to the point where the top touches the ground is 8 meter. So find the height of the tree. Okay, so here basically have given a tree that breaks due to storm and broken part bends so that the top of the tree touches the ground, making an angle 30 degree. Okay, and here we have given the distance between the foot of the tree to the point where the top touches the ground is 8 meter, and basically here we have to find the height of the tree. Okay, so let us solve it. So here you can see this diagram. So in this diagram we have this tree. Okay, so AC is tree when it was unbroken. Okay, so after broken by storm, here at some point A, at some point B, the tree breaks. Okay, and touches the ground at point A is. So let AC was the original tree. So AC is original tree. Due to storm, it was broken into two parts. The broken part A dash B dash. The broken part A dash B is making 30 degree with the ground. Okay, so now this triangle A dash BC, here BC by A dash C, this is equal to tan 30 degree. Okay, so BC by A dash C, this is equal to tan 30 degree, and we know the value of tan 30 degree, this is equal to 1 by root 3. Okay, so here we have given A dash C, this is equal to 8 meter. So BC by 8 is equal to 1 by root 3. So it implies BC is equal to 8 by root 3 meter. Okay, and also cos 30 degree, this is equal to A dash C by A dash B, and here we have given A dash C is equal to 8 meter. So 8 by A dash B is equal to root 3 by 2, since cos 30 degree is equal to root 3 by 2, and it implies A dash B, this is equal to 16 by root 3 meter. So height of the tree is basically adding A dash B and BC. Okay, so here we get the value of A dash B, this is equal to 6 by 16 by root 3 meter, and we get the value of BC is equal to 8 by root 3 meter. Okay, so now height of the tree, this is equal to 8SB plus BC, and now this is equal to 16 by root 3 plus 8 by root 3 meter. Okay, and if we simplify it, then you will get 24 by root 3 meter, and this is equal to 8 times root 3 meter. Okay, so hence the height of the tree is 8 times root 3 meter. So height of the tree is 8 times root 3 meter. And now let us move to next question. So in next question, here we have a contractor plans to install 2 slides for the children to play in a park. So for the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle 30 degree to the ground. Whereas for elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. So what should be the length of the slide in each case? Okay, so here basically it asks to find the length of the slide in each case. Okay, so let us solve it. So here it can be observed that AC, this is actually AC, and PR are the slides for younger and elder children respectively. So in triangle ABC, in this triangle here, AB by AC, this is equal to sine 30 degree, and it implies 1.5 by AC, this is equal to 1 by 2, since AB is equal to 1 by 5 meter. So 1.5 by AC, this is equal to 1 by 2, and it implies AC is equal to 3 meter. And in triangle PQR, here sine 60 degree is equal to PQ by PR. Okay, and here the value of PQ is equal to 3 and sine of 60 degree root 3 by 2, so it implies 3 by PR is equal to root 3 by 2. Okay, so 3 by PR is equal to root 3 by 2, and it implies PR is equal to 6 by root 3, and this is equal to 2 times root 3 meter. Okay, so therefore the length of the slides are 3 meter and 2 times root 3 meter. Okay, so let us move to next question. So in next question, here we have the angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree, and here we have to find the height of the tower. Okay, so basically here we have given the distance from a point on the ground from the foot of the tower. Okay, so we have given between this distance between a point on the ground and foot of the tower, that is equal to 30 meter. Okay, and here we have given the angle of elevation of the top of the tower that from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Okay, and here we have to find the height of the tower. Okay, so we need to find the height of the tower. So let us solve it. So here you can see this diagram. So in this diagram here, AB is basically the tower, and the angle of elevation from the point C on ground is 30 degree. Okay, so let AB be the tower, and the angle of elevation from the point C on ground is 30 degree. So in triangle ABC, here AB by BC, this is equal to tan 30 degree. Okay, so AB by BC, this is equal to tan 30 degree. So now we have BC, this distance is equal to 30 meter. Okay, so we have this distance is equal to 30 meter. So now we can put BC is equal to 30, then AB by 30, this is equal to 1 by root 3. Okay, and it implies AB, this is equal to 20 by root 3, and this is equal to 10 times root 3 meter. Okay, so AB is equal to 10 times root 3 meter, and therefore the height of the tower is 10 times root 3 meter. Okay, so the height of the tower is 10 times root 3 meter. And now let us see next exercise. So in next exercise, we have a kite is flying at a height of 60 meter above the ground. Okay, so you can visualize this. A kite is flying at a height of 60 meter above the ground. Okay, and the string attached to the kite is temporarily tied to a point on the ground. So the inclination of the string with the ground is 60 degree, and here we have to find the length of the string, assuming that there is no slack in the string. Okay, there is no slack in the string. So basically we have a kite that is flying at a height of 60 meter above the ground, and here we have the inclination of the string with the ground is 60 degree, and here basically we have to find the length of the string. Okay, so let us see how to solve it. So here you can see this diagram. So suppose here we have a kite. Okay, and from this point, this is our ground BC. Okay, and here this distance is 30 meter. Okay, and this inclination of this this is equal to 30 degree. So K be the kite, and string is tied to point P on the ground. So triangle KLP, from this triangle, so suppose this is KLP. Okay, so from this triangle KLP, KL by KP, this is equal to sine 60 degree. Okay, so here we have given KL, this is equal to 60 meter. So this implies 60 by KP, this is equal to root 3 by 2, and it implies KP is equal to 120 by root 3. Okay, so KP is equal to 120 by root 3, that is equal to 40 times root 3 meter. Okay, so hence the length of the string is 40 times root 3 meter. So length of this string, this is actually equal to 40 times root 3 meter. Okay, so basically we have given the height of the kite, that is equal to 60 meter, and here basically we use trigonometry ratio sine 60 degree. Okay, so sine 60 degree, and here 60, this is 60 degree. Okay, so sine 60, this is equal to KL by KP, and it implies 60 by KP is equal to root 3 by 2, and from this we get the value of KP is equal to 14 times root 3 meter. So hence the length of the string is 40 times root 3 meter. Okay, so now let us move to next question. So in next question, here we have 1.5 meter tall boy is standing at some distance from a 30 meter tall building. Okay, and the angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree. Okay, and as he walks towards the building and find the distance he walked towards the building. Okay, so the height of the boy is 1.5 meter, and he is standing at some distance from a 30 meter tall building. Okay, and the angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree. Okay, why this is increased? Because he walks towards the building, and find the distance he walked towards the building. So here you can visualize this. Okay, so suppose here some boy was standing at point S. Okay, so at this point boy was standing, and he walked towards the building, reach at the point T, and here angle of elevation is 30 degree, and here angle of elevation is 60 degree. Okay, so it can be observed that PR, this is actually equal to PQ minus RQ. Okay, so PQ minus RQ. So PR is equal to PQ minus RQ, and here you have given PQ is 30 meter and RQ, that is actually equal to height of the boy. Okay, so that is given to us 1.5 meter. So PR, this is equal to 30 minus 1.5, that is equal to 28.5 meter. Okay, so PR, this is equal to 28.5 meter, and you can write this as fraction, this is equal to 57/2 meter. Okay, so this is equal to 57/2 meter. And now in triangle PAR, here tan 30 degree, this is equal to PR by AR, and here we have given we found the value of PR is equal to 57/2. Okay, so here 57/2 AR is equal to 1/√3, and it implies AR, this is equal to 57/2 times √3 meter. And in from triangle PRB, here PR by BR, this is equal to tan 60 degree, and it implies 57/2 BR, this is equal to 1 by, this is equal to √3. Okay, so it implies BR, this is equal to 57/2 times √3, and this is equal to 19 √3 time divided by 2 meter. Okay, so BR is equal to 19 times √3 by 2 meter. And here ST is equal to AB, ST is equal to AB, and you can find AB as AR minus BR, and this is equal to 57/3 by 2 minus 19/3 minus by 2. Okay, 19/3 by 2 meter. So if we simplify it, then this is equal to 38 times √3 by 2 meter, and this is equal to 19 times √3 meter. Hence he walked 19 times √3 meter towards the building. Okay, so he walked 19 times √3 meter towards the building. And now let us see next exercise. So in next exercise, here we have from a point on the ground, the angle of elevation of the top of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. So find the height of the tower. So let us solve it. So here we have given AB be the transmission tower. So this is our transmission tower, and BC be the building, and D be the point on the ground from where the elevation angles are to be measured. Okay, so here D is the point where we measure the elevation angles, and here BC is the height of the building, and AB is the transition tower. So in triangle BCD, from this triangle here, BC by CD, this is equal to tan 45 degree. Okay, so it implies BC, this is equal to 20, so BC is equal to 20 meter, that is given to us. So BC by CD, this is equal to tan 45 degree, and it implies 20 by CD is equal to 1. Okay, and it implies CD is equal to 20 meter. So CD is equal to 20 meter. And now from triangle ACD, okay, so here from this triangle, here AC by CD, this is equal to tan 60 degree, and it implies AB plus BC by CD, this is equal to √3, and it implies AB plus 20 by 20, this is equal to √3, and it implies AB is equal to 20 times √3 minus 20 meter, that is equal to √3, that is equal to 20 into √3 minus 1, that is equal to 20 into √3 minus 1. Okay, therefore the height of the transmission tower is 20 into √3 minus 1 meter. Okay, so the height of the transmission tower is equal to 20 times √3 minus 1 meter. And now let us move to next exercise. Here in next exercise, here we have a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point, the angle of elevation of the top of the pedestal is 45 degree. Okay, and here find the height of the pedestal. So here we have to find the height of the pedestal. So let us find the height of the pedestal. So here let AB be the statue. AB be the statue, that is 1.6 meter, and BC be the pedestal. So this is our pedestal. So and D be the point on the ground from where the elevation angles are to be measured. Okay, so now from this triangle BCD, from this triangle here, BC by DC, this is equal to tan 45 degree. Okay, so BC by CD is equal to tan 45 degree, and here BC by CD, this is equal to 1. So it implies BC is equal to CD. So BC is equal to CD. So now from this triangle, from triangle ACD, here angle of elevation 60 degree, and here AB is 1.6 meter, and AC can be written as AB plus BC. Okay, so in triangle ACD, here AB plus BC by CD, this is equal to tan 60 degree. Okay, so here AB plus BC by BC is equal to root 3, and here we have given AB, that is height of the statue is equal to 1.6 meter. Okay, so 1.6 plus BC, this is equal to BC times root 3, and it implies BC times root 3 minus 1, this is equal to 1.6, and it implies BC is equal to 1.6 into root 3 plus 1 divided by root 3 minus 1 into root 3 plus 1. Basically here we get BC is equal to 1.6 by root 3 minus 1, and here we rationalize this, then we get the 1.6 times root 3 plus 1 divided by root 3 minus 1 into root 3 plus 1. Okay, and if we simplify it, then we will get this is equal to 1.6 times root 3 plus 1 divided by root 3 square minus 1 square, and this is equal to 1.6 times root 3 plus 1 divided by 2. Okay, and this is equal to 0.8 times root 3 plus 1. Okay, so therefore the height of the pedestal is 0.8 times root 3 plus 1. Okay, so the height of the pedestal is 0.8 times root 3 plus 1 meter. Okay, now let us move to next exercise. So in next exercise, here we have the angle of elevation of the top of a building from the foot of the tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. Okay, and if the tower is 50 meter high, and then we have to find the height of the building. Okay, so here we have to find the height of the building. So let us see how to find it. So here let AB be the building, so here AB be the building and CD be the tower. So from this triangle CBD, CDB, from this triangle here CD by BD is equal to tan 60 degree. Okay, and it implies we have given height of the tower is equal to 50 meter. Okay, so CD is equal to 50, so 50 by BD is equal to root 3, and it implies BD is equal to 50 by root 3. Okay, so BD is equal to 50 by root 3. And now from this triangle ABD, here AB by BD is equal to tan 30 degree, and we know tan 30 degree is equal to 1 by root 3, and here AB is equal to BD times 1 by root 3, and here we find the value of BD is equal to 50 by root 3. So 50 by root 3 times 1 by root 3, and this is equal to 50 by 3, and this is equal to 16 of 2 by 3. So therefore the height of the building is 16 of 2 by 3 meter. Okay, so the height of the building is 16 of 2 by 3 meter. And now let us see next exercise. So in next exercise, here we have two poles of equal heights are standing opposite each other, one either side of the road, which is 80 meter wide. From a point between them on the road, the angles of elevation of the top of the poles are 60 degree and 30 degree respectively. Okay, so find the height of the poles and the distances of the point from the poles. Okay, so let us see how to solve it. So here let AB and CD be the poles, and O is the point from where the elevation angles are measured. So AB and CD, they are both poles. Okay, and here O, that point from where the elevation of angles are to be measured. Okay, so triangle ABO, from triangle ABO, AB by BO, that is equal to tan 60 degree. Okay, so it implies AB by BO is equal to root 3, and it implies BO is equal to AB by root 3. Okay, so BO is equal to root 3, AB by root 3. And now in triangle CDO, CD by BO is equal to tan 30 degree. Okay, and it implies CD by 80 minus BO is equal to 1 by root 3, and CD root 3 is equal to 80 minus BO, and it implies CD times root 3 is equal to 80 minus AB by root 3, since BO is equal to AB by root 3. Okay, and CD times root 3 plus BC AB by root 3 is equal to 80. And since the poles are of equal heights, are of equal heights, so CD is equal to AB, and it implies CD times root 3 plus 1 by root 3 is equal to 80, and it implies CD times 3 plus 1 by root 3 is equal to 80, and it implies CD is equal to 20 times root 3 meter. Okay, and now BO, this is equal to AB by root 3, and this is equal to CD by root 3, and this is equal to 20 times root 3 by root 3 meter, that is equal to 20 meter. Okay, so the BO is equal to 20 meter and CD is equal to 20 times root 3 meter. So now DO, this is actually equal to BD minus BO. Okay, so BD is 80 and BO is equal to 20 meter. So 80 minus 20 meter, that is equal to 60 meter. Okay, so therefore the height of the poles is 20 times root 3 meter. Okay, and the point is 20 meter and 60 meter far from these poles. Okay, so the point far from the poles is 20 meter and 60 meter respectively. Okay, so now let us see another exercise. So in next exercise, here we have a TV tower stands vertically on a bank of a canal. Okay, so here this is our TV tower that stands vertically on a bank of a canal from a point on the other bank directly opposite the tower. So the angle of elevation of the top of the tower is 60 degree. So this angle is 60 degree. From another point 20 meter away from this point on the line joining this point to the foot of the tower, and the angle of the elevation of the top of the tower is 30 degree. Okay, so this angle is 30 degree. So you can see this figure. So here we have to find the height of the tower and width of the canal. So we need to find height of the tower and width of the canal. So let us solve it. So here in triangle ABC, here you can see this figure from this triangle ABC. Here AB by BC is equal to tan 60 degree, and this implies AB by BC is equal to root 3, and it implies BC is equal to AB by root 3. And now from triangle ABD, so from this triangle here tan 30 degree, this is equal to AB by BD. Okay, and it implies AB by BC plus CD is equal to 1 by root 3, and it implies AB by root 3 plus root 2 plus 20 is equal to 1 by root 3, since BC is equal to AB by root 3 and CD is equal to 20. Okay, so AB by root 3 plus 20 is equal to 1 by root 3, and it implies AB times root 3 by AB plus 20 times root 3 is equal to 1 by root 3, and it implies 3 times AB is equal to AB plus 20 times root 3, and it implies 2 times AB is equal to 20 times root 3, and it implies AB is equal to 20 times root 3 by 2, that is equal to 10 times root 3. Okay, so AB is equal to 10 times root 3, and now BC, this is equal to AB by root 3, and here we get the value of AB is equal to 10 times root 3, so BC is equal to 10 times root 3 by root 3 meter, that is equal to 10 meter. Okay, so therefore the height of the tower is 10 times root 3 meter and the width of the canal is 10 meter. Okay, so the height of the tower is 10 times root 3 meter and the width of the canal is 10 meter. And now let us move to next exercise. So in next exercise, here we have from the top of a 7 meter high building, the angle of elevation of the top of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. So determine the height of the tower. Okay, so here we have to determine the height of the tower. So let us solve it. So here you can let AB be the building and CD be a cable tower. So AB here be a building and here CD be a cable tower. So from this triangle ABD, so AB by BD is equal to tan 45 degree, and here AB is 7 meter, so 7 by BD is equal to 1, and it implies BD is equal to 7 meter. Okay, now from this triangle ACE, so here from this triangle ACE, here A is equal to BD is equal to 7 meter, and here CE by AE, this is equal to tan 60 degree, and we know tan 60 degree is equal to root 3, and here AE is equal to 7 meter, so CE by 7 is equal to root 3, and it implies CE is equal to 7 times root 3 meter. And we know CD is equal to CE plus ED, and here C is 7 times root 3 and ED is equal to 7 meter. So CD is equal to 7 times root 3 plus 7 meter, and it implies this is CD is equal to 7 times root 3 plus 1 meter. Okay, so therefore the height of the cable tower is 7 times root 3 plus 1 meter. Okay, so the height of the cable tower is 7 times root 3 plus 1 meter. So I stop here this lecture. Thank you very much to all of you.